In this video, I plan on introducing predicate logic semantics. I'll need to break up the discussion of predicate logic semantics over a course of a number of videos. So here we'll set the stage by talking about how predicate logic semantics differs from propositional logic semantics and introduce one of the core notions, which is the notion of a model. So the first thing to note is how predicate logic semantics differs from propositional logic semantics. In the case of propositional logic, well-formed formulas are assigned a truth value, T or F, in a sort of two-step process. First, there's an interpretation function. And what this interpretation function does is assign a truth value, T or F, to all of the propositional letters in the language. So if you have an uppercase P or Q or R, it will assign it either a value of true or false, not both and not neither. Next, once we have truth values for the propositional letters, well-formed formulas in the language, conjunctions, conditionals, and so on, are assigned truth values using a valuation function. Essentially, what the valuation function does is take the truth value that's assigned to the propositional letters, and given the type of formula it is, will determine whether or not the entire formula is true or false. The semantics of predicate logic is a little bit more complex in that the elementary symbols that we have don't express complete propositions. They don't express the types of things that can be true or false. Instead, one way of thinking about it is they express parts of propositions. So we need to go about assigning their meaning, the meaning of the symbols of predicate logic in a different way. So what do we need with respect to predicate logic semantics? We need essentially two notions. The first is the notion of a model. And a model is essentially a two-part structure consisting of two things. First, it consists of a domain of discourse, which we'll talk about more in a moment, and it consists of an interpretation function. Once we have this model in place, we'll also, similar to the language of predicate logic, make use of a valuation function, which will take well-formed formulas and determine whether or not that formula is true or false with respect to that model. So let's talk about the two parts of the model. The first part is the domain of discourse. Now, a domain of discourse is simply a set of items or of things. The domain is either restricted or unrestricted. If it's unrestricted, then the domain consists of anything you want, all the things that could possibly be talked about. Most domains are not unrestricted. Rather, we talk about restricted domains. We talk about specific collections of things. In order to restrict the domain or specify the types of things that we're going to talk about, we can do this in two different ways. First, we can list or name each of the individual items in the domain. So if we want to talk about our favorite movies, we simply just name each of our favorite movies. Another way of talking about or restricting or specifying the domain is to just indicate the property that all of the items in the domain have. So rather than going through each individual item in the domain and naming it or pointing it out or picking it or indexing it, we say all the things that we're talking about have this particular property. So let's look at two examples or a couple examples of the ways we might specify a domain. So if we wanted to talk about four people, let's say we wanted to talk about David, Liz, Tech, and Ryan, we could specify the domain that these are the things that we're talking about. This is a collection or set of things by simply naming them all off. We say David, Liz, Tech, and Ryan. So we have the symbol for domain, this D right here, and we simply rattle each of their names off. Another way of kind of putting this is if we wanted to talk about letters, A, B, and C, or we wanted to say that we just want to talk about these like dummy objects, they don't really stand for anything, we could simply list them A, B, C, and D. The other way of listing or specifying a domain is, rather than individually naming them, to specify the property that all the things have. So if we wanted to talk about human beings, we don't want to talk about movies or numbers or shapes or buildings, we only want to talk about, let's say, human beings. Then we simply say that the domain consists of the set of things that have the property of being a human being. Let's talk about the first function of the interpretation function. So the idea here is that the interpretation function, which we designate as I, it looks at each name in the language of predicate logic and then assigns it an object in the domain. So let's say our domain consists of a set of integers, 1, 2, 3, so forth and so on. Now, what the interpretation function does is looks at all of the names in the language. So, you kind of go through all the different ones. And what it will do is pick out one and only one object from the domain that it refers to. So when we say we are going to interpret the name A, we interpret it in terms of some single object in this domain. So we might say the interpretation of A is 1, and the interpretation of B is 2, and the interpretation of C is 3. One thing worth pointing out here is that while every name is interpreted, it's not necessary that a name, it designates or denotes a specific object, that object in the domain cannot be designated or denoted by another name. So it's helpful to think of intuitively. We might say that an individual, let's say David, an individual name David refers to, let's say, me. My name is David Agler, and so it kind of picks me out. But I also have other names, nicknames. And so if here's my nickname, it refers to, again, the same individual, David. So here we have two different names, but they refer to the same object, which is me. The same thing is the case with respect to predicate logic. We can say that, let's say, the interpretation of A refers to the number 1. It also might be the case that the interpretation of, let's say, E also refers to number 1. So once a name has been interpreted in terms of an object in the domain, it's open, or it's at least possible, that the interpretation function will also assign other names that same object. Let's look at the second function of an interpretation. The second function of an interpretation is to assign or give the meaning of n-place predicates. And the definition of it simply says that we take that n-place predicate and it's interpreted in terms of a set of n tuples. Now there's quite a bit of jargon there, so I'm going to try to break this idea down into a couple parts. So let's look first at the scenario where R is a one-place predicate. What an interpretation function would do here is assign it a set of objects from the domain. So let's let the domain consist of this set of numbers 1, 2, 3, 4, 5, and 6. So what an interpretation function would do here, the interpretation of R, would just pick out a collection or group or set of objects that are drawn from the domain. So we might say the interpretation of R is simply the numbers 2, 4, and 6. Or we can think of it as saying R picks out the even numbers from this collection of numbers 1 through 6. And you can think about this in other examples. If we have, let's say, the domain of people, living human people. And we might have a one-place predicate that stands for something like is tall. And so what the interpretation of is tall would be is simply the collection of people from the domain that have the property of being tall. So it would pick out all of the people who are tall people. It would just kind of go through all of the items in this domain here and select the tall ones. If R is a two-place predicate, what type of thing does it pick out? What type of set? So if R is a two-place predicate, what the interpretation function does is assign it a set of ordered pairs from the domain, or over the domain. A set of ordered pairs, or rather an ordered pair, is a sequence of two objects. And we can symbolize an ordered pair using angled brackets. So if we had a ordered pair, or kind of two objects that are put into an arrangement or sequence where the order is important, and A is the first object and B is the second object, we could express this, that A and B are an ordered pair, by writing this left angled bracket A and B, and then a right angled bracket. So this expresses that A and B are an ordered pair. Let's look at this in a little bit more detail. So let's talk a little bit about what an ordered pair is in some slightly more detail. So we can think about an ordered pair as a special kind of set where the order of the items is important or significant or means something. So one way of thinking about an ordered pair is in contrast just to a regular set or collection. So let's say we're talking about two people, John and Tech. And we'll let John, we'll represent that as lowercase j, and Tech as j. And so let's kind of draw John and Tech here. Here is John, and here is Tech right here. So here's John with the j, and here's Tech with the t. Now, if we're just talking about these individuals as being part of a collection, and we don't really care about their arrangement, we just want to talk that they're a member of the group of the things that we're talking about, then we can express this set or this collection simply as j or t, or we can express it as t or j. So here we're expressing this collection, but both of these collections are saying the same thing. We're just talking about all the items that are found in this set, and the order in which they occur, or the number of times in which they occur, also doesn't really matter. And so they're equal to each other. But let's say we wanted to talk about a set of individuals where their placement or their arrangement or their is important. We want to talk about the collection of individuals, or where the first individual has a particular type of relationship to the second individual. And so one example is we can think of the taller than relationship. We can think of a set where there are two individuals, and the first individual in the set is taller than the second individual. So in this case, when we look at John and Tech, we see that John here, he's taller than Tech. And we want to be able to express this. And so we write j, the first individual, is taller than the second individual. So we express this relationship that John and Tech have in terms of each other as an ordered pair. The first individual is taller than the second individual. And this is not identical to the order, in contrast to the sets that we looked at up here. This is not identical to the ordered pair where the first individual is Tech and the second individual is John. So all this ordered pair is a special kind of set where the order or placement of the objects in the set or sequence is significant or plays an important or informative role. Going back to our discussion or the statement of what an interpretation function does, we see that the interpretation function, as it's stated, assigns a set of n tuples from or over the domain to n-place predicate terms. And we haven't really explained what an n tuple is quite yet. So it's helpful to use what we talked about before to kind of trigger an understanding of what an n tuple is. So we can talk about single objects in a set. So A, B, C, D. These single objects are known as one-tuples. We can talk about ordered pairs, a kind of set where the sequence or order matters. So A, B, as well as, let's say, C, D, this ordered pair. These ordered pairs here are also referred to as two tuples. They have two items. They're an ordered arrangement or ordered set where there are two elements in this ordering. And you can think of, kind of go on and on with respect to this. You could say, well, we can imagine a set that is ordered, and that set has three elements. So A, B, and C. And this three-element ordered sequence is a three-tuple. And you can go on and on and on concerning this. And so you can say that an ordered sequence of n elements, where you just have some number of ordered elements, this is an n-tuple. So however many it has, that will kind of characterize the n in n-tuple. So what the interpretation function does is it assigns a set of n tuples from items in the domain to n-place predicate terms. And so if we interpret something like R, and R is a two-place predicate, what we'll expect to see is a set of things where each of the items in this set, given that R is a two-place predicate, is a two-tuple. And so we might see A, B, as well as, let's say, B, the ordered pair B, A, and onward and onward. But each of the items in the set, given that R is a two-place predicate, will be a two-tuple. So let's look at an example of this. Let's suppose that G is a two-place predicate. And it might be helpful in understanding this, the kind of first go around, is to understand it in terms of an English two-place predicate. Let's say it stands for greater than. So what the interpretation function will do is assign it a set of two tuples over D. So the elements in these two tuples will be found in the domain. Now let's specify a domain. To keep things simple, let's say we have a domain and it consists of the numbers 1, 2, and 3. So the interpretation function will kind of assign names to items in the domain, but what we're interested in unpacking here is how the interpretation function behaves with respect to this two-place predicate G. So what the interpretation function will do here is pick out a set that has elements that are two tuples where the first number is greater than the second number. And so if we look through this 1, 2, 3, we're going to say that the interpretation of G is going to pick out ordered pairs or two tuples where the first item is greater than the second item. And so we see that 3 is greater than 2, 3 is greater than 1, and 2 is greater than 1. So it's going through this domain, going through each one of the objects in the domain, and it selects a pair of things where the first item is greater than the second one. So let's put all of the things that we've talked about together and apply it to a particular example. So we're going to take the whole notion of a model with respect to the domain of discourse and the two roles of the interpretation function and look at a specific example. So let's take the example of three circles. And just to make things easier, to kind of refer to them in an easier way, we're going to label these three circles 1, 2, and 3. So our domain consists of these three circles and nothing else. The next thing is the interpretation function's role in going through the names of the language of predicate logic and assigning them an object in the domain. And so let's take the name A and say it refers to the blue circle, or what we've designated as the number 1 here. So we say the interpretation of A here, it refers to the blue circle. Next, we need to interpret B. And we say that the interpretation of B here, what does it refer to? Well, it refers to, from the domain, the red circle. Finally, the interpretation of C, well, what does it refer to? Well, it refers to this green circle. Now, one of the things is that the interpretation function goes through all of the names of the language of predicate logic and assigns it an object in the domain. And since our language has not just the names A, B, and C, what is often done when required is to add some kind of part where it says, and something like, and all other names, and you just kind of designate some object in the domain. So you say the interpretation of, let's say, D onward, all those refer to, let's say, the green circle. A lot of times this is left out because it won't play a role in evaluating different formulas, but this is part of the definition of the interpretation function. Now that we have an interpretation of all the names, the next thing the interpretation function does is assign sets of n tuples to the n-place predicate terms. So it's going to interpret the meaning of those n-place predicate terms in terms of a set of n tuples drawn from or over the domain. So let's look at this particular example that we have here. So let's take 4 one-place predicate terms and then 1 two-place predicate term. So what the interpretation function is going to do is assign these terms some meaning. So let's say this one-place predicate term C, it stands for is a circle. We designate that each one of the items from our domain is in the interpretation of C. When we go to interpret B, let's say B stands for something like is blue, then it's going to pick out the items from the domain that are, let's say, blue. And so since circle 1 is blue, it selects in its interpretation just this first circle right here. If R stands for is red, then it'll pick out the red circle. If G stands for is green, then it'll pick out the green circle. Now the last interpretation is the interpretation of the two-place predicate term. And just for heuristic purposes, let's say L stands for is larger than. And so what this interpretation function will do is it'll pick out ordered pairs or a set of 2 tuples where the first object from the domain is larger than the second object. What this interpretation is larger than does is it selects objects where the first circle is larger than the second circle. So since 3 is larger than 2, then it selects this ordered pair where the first object is larger than the second one. We also note that 3 is larger than 1. This third circle right here is larger than the first one. So it's going to pick out this ordered pair where the first circle is larger than the second circle. And since this second circle right here, this red circle right here, is larger than the first circle, it's going to pick out this ordered pair where circle 2 is larger than circle 1. So this is a complete example of a model. We have 1, the domain of discourse, the items of which we're going to talk about, and then we have our interpretation function, the other main part of a model. With respect to the interpretation function, we have the interpretation of names, which simply selects objects, single objects from the domain. And then we have our interpretation of all of the predicate terms, which selects sets of n tuples over the domain. So it's only going to pick objects that are found in the domain. It won't pick anything else. So just to conclude, the semantics of the language of predicate logic consists of 2 parts. The first part is what has been covered in this video. This is the notion of a model. And the model consists of 2 parts, which is this domain of discourse and the interpretation function. In the next video, what we'll look at is the other part of the semantics of predicate logic, and this is the valuation function. What the valuation function will essentially do is take formulas from the language of predicate logic and using the model, so with respect to this model, it will assign these formulas truth values, true or false. And it's going to do that by using or utilizing this model. So this notion of a model is important because if you don't have a clear grasp of what a model is or how to construct one, this valuation function won't mean anything to you because the valuation function only works relative to this model.